Hello everybody, welcome to today's lesson, Forces Unit 1, Lesson 1, about balanced and unbalanced forces, and we'll do a little bit of work on resultant forces as well today. For this lesson you're going to need a few bits and pieces. You're going to need a pen or a pencil, something to write with, piece of paper or a book, something to write on, and you can use a calculator if you want to help you out with the maths. If you don't have those things, go pause the video now, go and get them, and then when you're ready to get going, press play again. Okay, let's get started. As always, we start with something that you have done before, something you should have covered probably in year 7. So, a few little questions. Pause the video, write down your answers, and then we'll go through the answers. Okay, time to get going then. So, question number 1, what unit is force measured in? Force is measured in newtons. Either you write out the word newtons as it is on the screen, or you can use a capital N for that. A lowercase n is not acceptable. It means something different. It is the wrong answer if you put that. So capital N is absolutely fine instead of the word newtons. What is a contact force? It's when things touch for the force to act. It's the touching bit that is important. As long as you've got touching in there, or it touches, something like that, you've got the answer correct. Examples are friction, air resistance, tension, etc. If you've got air resistance, people say, yeah, air resistance, what's touching? Well, of course, it's the air particles that touch the surface. They collide with the surface that causes the force. A non-contact force, very similar to the contact force, but this time you don't have to have things touching or no contact for the force to act. That's the important bit. Examples of non-contact forces: gravitational force, electrostatic force, magnetic force. Those would be 3 great examples, any 2 of those. If you've got those all right, or you've got them mostly right, well done, excellent. Let's carry on. So we start today's lesson, then the new material, by having a look at this. This is a picture of a tug of war. With a tug of war, the way it happens is you've got right down the middle, as you can see, you've got 2 teams. This team over here is pulling that direction, and this team in the foreground is pulling this direction. And the idea is that the winning team pulls the other team forward. In this case, past the cones. They've got a little marker a bit tight in the middle of the rope, and once it gets to the outer cone, they win. In the olden days, very traditional sort of game, what you would have is a river down the middle, and the 2 teams would try and pull the other team into the river. The reason for that is because in olden days, before we had lots of lorries and things, a lot of goods were transported by barges up canals and things and up rivers. And what you'd actually find is most towns, for convenience, were built near rivers so they could get their food and other goods quite easily. But that's the idea. Now let's model this then as a diagram. So you've got, quite simply on our diagram, 3 people trying to pull to the left, 3 people trying to pull to the right. Now, what you need to do is give each of those a direction of pull. These are going to be to the left, those to the right, and a force. So let's add those in. This person, for example, is pulling with 400, this one 600, both to the left, the other side 500 to the right, and so on. So what happens? Tug of war, what happens? So I'm going to pause the video now, and you can write down what you think the answer to that is. And then when you're ready to go through the answer, press play again. Okay, let's go through the answer. What should you have done then? Well, what I would have done is I've added these 3 forces on the left together. 400 plus 500 plus 600 makes 1500. So those 3 forces can be represented by one force of 1500 to the left. This is called a resultant force. It's the one force that is the same as all of those forces there added together. This here is the 1700 is these 3 forces on the right added together. Again, a resultant force. It's these all added together, 800 plus 400 plus 500. So you've got 2 resultant forces, one for this team, one for that team. You can do a resultant force overall, and that is the equivalent of 200 newtons pulling to the right, 1700, take away 1500. So what can we say? That we can say the resultant force is 200 newtons to the right, therefore the rope moves right. and the team on the right wins. Okay, so let's jot down some notes then. So on your book, or on your piece of paper in your book or whatever, copy that this statement down onto your book. Go around it with a box, with a ruler or a highlighter pen, whatever's your thing. Pause the video, and then we'll go on to some more stuff, some practice questions in a moment. Okay, so let's do another question then. So once again, two teams. I want to know what happens. Pause the video, and then we'll go through the answer. So then, let's have a look. This is what you should have done. Add all the forces together going left, the 5, the 6 and the 600, which should come to 1700. Do the same thing on the right, which should have come to 1400. The answer then would have been the resultant force of 300 newtons to the left. The rope moves left, the team on the left wins. I don't know if you got that right. Let's have a go at another one. So pause the video again, have a go at your answer. Let's see how you've done them. So once again, add all the ones on the left together, that is 1500 newtons. Add all the ones on the right together, that is 1700 newtons. So the answer this time, the resultant force is 200 newtons to the right. Rope moves to the right, the team on the right wins. You got that right? Well done. Let's have a go at another one. Let's think of this one. So see how you got on. What you should have done is added all the ones on the left together, 1600 newtons. All the ones on the right together, 1600 newtons. This is interesting because both the forces are the same. So what we can say is the resultant force is 0. The forces are balanced. The rope does not move. It's a draw. Okay, you got that right. Well done. Let's see what we can record about that then. So we've already got that one. Resultant force is a single force that can be used to replace several other forces acting on an object. So add 2 more statements to it. Pause your video, write that down. Little mini test for you. Let's spend about a minute just reading through those statements that you've just written down, those statements there, and then you can turn your page over or start a new sheet. The idea is that you're not looking at the answers when you answer the questions. Okay, pause the video now for 1 minute to do your revision. Okay, here's the questions then. Pause the video, write in your answers, and press play again when you're ready. Okay, so the answers you should have got would have been the same as what you've written down previously. So let's just bring those back up. If you've got them all right, well done. If not, just spend a couple of minutes going over them again, read them again, maybe even have a go at the mini test again on another blank piece of paper. If you've got them all right, as I say, well done. Thank you very much. That's all, folks.